Hello, everyone, and welcome to the Development and Testing Strategies presentation. Our speaker today will be Grahame Grieve. Grahame, would you like to take it away, sir? Let me make sure. Not sure. Unmuted here. Kristen, are you able to unmute Grahame? Seems like he's still muted on the Zoom side.
Sorry, hello everyone. Sorry
there it is, fantastic.
You'd think by now, I don't know, never mind. I think you're gonna have that sorted out, but never mind. Hello, I'm Grahame Grieve, FHIR Product Director. Okay, when we talk about testing, development and testing strategies, I'm going to talk about what features FHIR has that support product development and application testing, and what challenges you're likely to run into. And it's probable that our discussion will uncover opportunities for further development, either in the specification or in the tooling ecosystem around FHIR. So I was thinking about how to structure this talk. I'm thinking that there's really three different parts to your problem when you are facing an application, particularly a server application written in FHIR, but it doesn't have to be a server. You're going to have some storage issues. Do some kind of storage. You can write clients that don't have any storage, but a lot of clients do have storage, and servers certainly do, one way or another. And then you're going to have some issues around content, which is where most of the work is, because healthcare content's complex. And then issues, design, questions around transport. So in terms of storage, I'm not talking about storage, but a key design strategy is whether you should store your content internally using FHIR or whether you should use a database, like a relational database. And we've had a bit of discussion about that through the last couple of days. I already spoke about that, and the videos of the presentation is available. Another question that frequently arises around application development strategies is around how to handle multiple versions of FHIR. I spoke about that as well, so there are references for you to follow up with. Now I want to talk about managing content. At the content level, FHIR is really a two-layer specification. It's very much increasing, that's how we encounter the specification. There's the base FHIR specification, the definitions of the types, both the data types and the resources, and it also lays down the way the definition infrastructure works. And so actually the FHIR standard uses its own definitional infrastructure to allow for profiles. So it's, consistent methodology. So that defines all the things that can be. This can exist, what can be done, and it's got extensibility built in, but the platform defines all the types. These are the things that can be done. And then we publish a set of profiles, and profiles, it's really important to understand when you come to do application development, what they are and what they're not. A profile is a set of rules about how to use a particular resource. They're not a type definition. They're just a statement of rules about how a resource is used. We present them in a very structured fashion, but they're not a type. And the resource may declare that profile that it conforms to, but the resource may be subject to the profile, even though it doesn't declare that it does or didn't know about it. Whoever wrote the resource had no idea. In fact, the profile might not have existed yet, but it still might meet those rules. So there's both one or more profiles that are asserted in the resource, and then there's all the other profiles it conforms to. So profiles are provided as a structured definition with supporting value sets and code systems. that fully define the possible content of a resource that conforms to the particular profile. So that's the specification and the implementation guides. That's what they provide. Then we provide, as a development framework, a bunch of reference implementations. So the first thing to say about developing a application as a development strategy is use a reference implementation if you possibly can. Now, there's some reasons why you might not, but if you possibly can, use a reference implementation. They've had a lot of eyes looking at them. They've had a lot of work, very large amount of work for the two main ones. And it just saves you so much time. So the first characteristic of reference implementations is they're very focused on the platform specification level, the FHIR level. They implement the types, both the data types and the resources, correctly. They're often extensively tested. Most of the reference implementations that are out there include an object model or an abstract syntax tree, or there are a bunch of words for what that is, the object model. They include parsers to read and write wire format, JSON or XML, to and from the abstract syntax tree. They often include a bunch of utilities for dealing with the object models to make that easier. And usually they include some kind of client, because even servers need to be clients to other servers. Some of the reference implementations include Smart App Launch supporting the client. Some of them include some form of visual widgets to make app development easy. Some of them include a validator so that you can do formal validation of your content inside your code from the reference, using the reference platform. So for my way of thinking, you'd be nuts not to use this, but not everybody can. So first of all, here's a list of the common reference implementations. There's maybe 5 others that I know about that are not on this list. And there are others for these platforms, but these are the primary ones. So there's, on Java, there's Happy, and that includes the code that the specification itself, the tools that work with that are written in using the Java implementation. There's the .NET implementation, JavaScript. There's a bunch of other languages, JavaScript, Python, Pascal, Swift, Dart. There's more Ruby. Yeah. So, and some of those are shortcuts, and there's a link at the bottom of the right, on the right of the slide, that has got a list of all of the implementations. If you're listening to this and you're thinking, hey, my implementation's not on there, and it should be, well, go and make sure it's on the Confluence page, because that's where that's the highlights from the Confluence page. And that's where we would direct people to if they said, hey, is there an open source reference implementation for X? Now, if you can't use one of those object model, one of those reference implementations, and well, there are people who can't. They have internal, first of all, they're not using a platform for which there is an object model. That's the first possible thing. So a reference implementation. Or maybe you've got internal standard, an internal architecture that requires your own custom developed abstract syntax tree. Or maybe you've got corporate standards. There's a bunch of reasons why people might not use the reference implementation. On the client side, maybe it's just too much work. You're just going to grab some JSON off a HTTP address, render it to the screen, make some changes, and throw some JSON back. So in that case, we don't need a reference implementation at all. And quite a few clients are often written that way. But then you're not really going to be saying, well, how do I roll my own equivalent? Because you're not going to. But in some of those other cases, you'll be going, well, how do I actually generate code? So the FHIR specification provides a number of possible sources for generating object code. So the structure definitions that are in the packages that are part of the core specification, they are a much richer source of definition than anything else. And I encourage people who are working with, code generation to start with the structure definitions. We do provide XML schema and JSON schema. We actually provide two variants of the XML schema. There's a code generation variant specifically for if people wish to use XML schema to generate code. It doesn't enforce choices, for instance. It just focuses on getting the structure correct, because we found that it's more code generation tools support that. But it only supports XML. It's a path towards specific XML support. Now, there are people with XML tool stacks that like that. And the schemas, we test the schemas and they're correct. It's just they don't implement and test a whole bunch of stuff the structure definitions know about, because can't do that in schema. JSON schema is a little bit more difficult. The JSON schema, there's a number of technical challenges with JSON schema, and my experiences using the JSON schema is one of the more common questions on chat.fhir.org to do with issues inside the JSON schema specification, and particularly the fact that the Open API specification uses custom JSON, and we're still trying to figure that out. A bunch of people have code generated from the Excel spreadsheets, but they're deprecated and going away, and I strongly encourage people not to use those. And we do provide a bunch of RDF definitions, and if you're really an RDF freak, then you could make that happen. But I don't think anybody's ever done that, and I wouldn't recommend it. But all of those are about generating the platform types and resources. See, you've been doing the equivalent of what the reference implementations do. Now, the common question is, what about profiles? And it's a pretty frequent question in implementation forums and to the experts and on chat.fhir.org. Can you generate code for a specific profile? And the trouble is, this is not an easy question to answer. So first of all, profile is a set of rules. So we might make a rule that for this particular observation, the code in the observation will be X and the status will be Y, set values. So the resource that you're reading can conform to those rules. It would be quite common to find a resource that says, well, I do have a code of X and my status is Y. I don't know anything about your profile, but I do. And so the resource can conform to the rules. So how do you know whether to read it as that profile or not? And that's, well, you have to actually validate it to find out whether you can, or you could try and maybe it'll go wrong. Another common thing is that a resource can conform to multiple profiles, because there's lots of profiles out there saying code must be X, status must be Y. So which one of those is it? And here's a thing that's very common. I'm going to do a search of observation. I'm going to get back 100 observations from the server. They're going to cover a bunch of different kinds of observations with a bunch of different profiles applicable to them. But my parser doesn't know anything about the rules for content to profile conversion. It's got to read the resource before it figures out the profile. But the way profiles behave, they're not types. A lot of people come and say, well, it's a subtype, but actually it's not behaving like a subtype here. And code generation always includes types. Now, doesn't mean you can't generate code. You could generate a facade. So it's a set of object classes that you attach to the underlying resource and try and read the resource as if it's one of these. And the facade expresses exactly what the profile implements, and it does the translation through to the underlying resource. So you make a series of objects. You decide, because of what you're doing or because of the content of the object, that you're going to treat it as if it's this particular profile, and you have profile specific code that you attach to it. And so the idea is you generate those facades from the profiles, and then in code you get profile specific use of the resources. It's actually on my to-do list to have a go at putting a generator for this inside Happy to generate facades. I've heard that other people have done that, but as far as I know, nobody's contributed code to do that. It's also possible to generate factory code. So it's really just a bunch of procedures, maybe wrapped up in an object, that take the kind of, you actually mine the profile and figure out what actual data an application has to inject. You know, a particular code, some text, and then you actually generate code that takes those as parameters. And so the user, all they have to do is work through those constructor methods on the factory and fill out the data they have, and bingo, out the other end comes a valid resource. You could do that. I have not yet tried to do that seriously. Maybe that's something that could be done. And for me, that's not a bad idea, because reading a resource is the harder part, but reading a resource by a particular profile is potentially problematic, which we'll come back to. So both of those are research questions for me, and maybe other people want to have a go at them. So one of the interesting things that I said, and this I think is really important, is when you set out to write your application, everybody starts with a clean sheet of paper and focuses very narrowly on the things I need to do now. I totally get that, because well, I do that too. And then you spend a lot of time reworking, because now you've discovered the things you need to do later. So from that perspective, I've learned a few things about things that you should do when working with profiles. So when you are populating resources, it's always tempting to say, I'm going to put as little as I can in the resource. Every piece of data I put in a resource is a piece of data I have to validate. I have to have heartache over whether it's valid and how to make it valid and test it, and it's going to create documentation. And so it's really tempting to say, I'll put the minimum amount of data present. Even if I have more data, I'll leave it out. And what I found is that's, yes, it's less work in the short term, but it's longer work, because in the long term, you realize you've got another use case, you're looking at your existing use of the resource, populating it with minimum amount of information. You need to put some more information in. Will that break your existing interfaces? What's the downstream cascading effect of adding to what you already have? Whereas if you actually put it in the first place, it's already there, and the new use cases just happen. And it's only a problem if you actually get asked for information you never had in the first place, so you could do a bunch of system development. So from a long-term perspective, my advice is fill out as much information as possible, even if the profiles don't require it. Of course, you can't put in something that the profiles make illegal, so come back to that. When you're actually doing extensions, then it's always worth doing the homework, searching for existing extensions. I know that that's not as easy as it should be, and it's a to-do for the community to make that easier. I'm working on it. And also to do the homework to declare the extension. I know that should be easier, working on it. And the other thing is that whenever you're working with resources, you should regularly and often perform full validation on the resources. You can build the validator into your testing, automated unit testing. It's suitable for that, people do. It's always a good idea, and always test everything early. When you are reading resources, on the other hand, and this is really Postel's theorem, write carefully, read generously. When you're reading resources, the first piece of advice, it's really easy, and I know lots of systems do this, the first thing they do when they see a resource is run it through the validator. Totally get why you would do that during development. And so then people roll that out into production to protect their system from unexpected data. The trouble with that is the validator tests everything. The validator is very thorough. And there's some things you should always check, which I'll come back to. But actually, when your system rejects a valid resource because the system configuration's changed, and it's now a change in a field you don't really care about, but you just imposed a very large financial cost on the maintainer of the system, who suddenly has to scramble to fix a problem that's really irrelevant. So I think that it's a very good idea to only validate the elements that you actually depend on and just ignore everything else. It can be whatever it is. I understand that there's plenty of architects who will go, this is never, ever going to do that. But, you know, count the cost. I think that because you're reading resources, there's always a risk that your code misreads a resource. It's one of the reasons why narrative is present in the resource. If you offer the user the choice to see the narrative, they've always got the ability to go, oh, I don't think that's what it actually meant. And I was thinking about that listening to Chris earlier today, talk about missing medications because doctors couldn't see them. That would be the equivalent of that, and it's kind of a pernicious problem. But you do have to pay particular attention to security issues in Markdown and XHTML. And I do recommend that everybody checks their reading code using offensive resources. I have a few of these, and it's on my to-do list, or someone could pick it up and say, I'm going to publish a collection of offensive resources. Those are resources where you're deliberately trying to put in invalid. Well, they're not technically invalid because the validator will pick them up, but they're hacky kind of values, mostly in Markdown and XHTML, to see if you can trick a system into misbehaving. And you should always check your reading code that reads resources using those. So some classic examples of those would be a string field like a name that only has a non-white space Unicode character that's a white space. Will your system blow up? An XHTML that has a reference to a schema. Will your system try and load the schema? An XHTML that has a reference to an image that doesn't exist. What'll happen? Those kind of, you know, trying to play with your parser to see if your parser is robust. So you should always build those into your tests. If you are designing profiles for resources, now here I'm going to be controversial. I know that there's people who want to argue with me about this. This is the fun bit. I think that you should always ignore fields you don't care about and say as little as possible about the resource. It's always tempting. I'm looking at a resource. I go, oh, I don't want a category. I am not interested in category. Go away and set it to 0. And I totally understand. It gets back to the short term versus long term. In the long term, a system like that you'll find just can't. It's not general purpose. It's not reusable. It's fragile. You basically have to re-engineer everything because you nailed everything down, and your code is unnecessarily inflexible. So I encourage people when designing profiles to only mention the fields they care about and just ignore everything else. Another common problem that I see is profiles that don't cover terminology sufficiently. Invest in the terminology part, the value sets in the code systems. And the other thing I strongly encourage is it's pretty easy when you're an architect and you're thinking about reuse, which I was just talking about, to try and get a real nice big stack of profiles that reuse things as much as possible. But what we found is more depth, there's more complexity and fragility in the design of the resources themselves, the profiles themselves. There's a trade-off. The more you go for shallow profiles, the more duplication you'll have across the profiles. The more go for depth to reduce duplication, the more fragility you'll get in your profile design. So, there's a trade-off between those two things. Now, when you are working with content, I strongly recommend that everybody reads the clinical safety checklist. Now, I say this every time. Every time I speak at every DevDays, I say, read the safety checklist. But nobody does. And I know that because nobody complains about what it says. And it's the most uncomplained about page in the FHIR specification. But we learned this the hard way by watching people make mistakes. I wrote it based on what I'd seen people do in production that led to actual problems. There's a few things that have been added since that we hadn't observed problems, but these are hard-won knowledge. There's 42 check items. Some of the items won't be relevant to you because of the kind of implementation you're doing or the features you're using. And it's not, and they're not simple. They're like, have you thought about this? Have you thought about that? And sometimes the answer is, yeah, I did, and it's fine. And other times it's like, I don't even know whether it's relevant. And if you don't know whether it's relevant, you probably should find out. And that might not be easy. But my experience with sitting down with real world implementers is they go, I hadn't thought about that. And I can tell you that we have some large content distributions around the world that haven't thought about some of those issues that are running clinical safety issues. So I highly recommend that people use the clinical safety checklist. Right. Now I'm going to turn my attention to transport and basically I'm focusing on the RESTful API because that's the only bit where we have computable definitions. So we define the resources capability statement, search parameter, and operation definition. These specify what your API is on the RESTful server and provide documentation about the operations and can be used operationally by servers or at code generation time. So you can generate and automatically implement search parameters. There's enough information in the search parameters to implement about 95% of them, and most of the general purpose servers do that. Anybody here still using R2 couldn't do that. It wasn't in there, but we went through and populated it after that. So there's a few search parameters you have to code by hand, but most of them, all the information you need is in the search parameter definition. I mean, you can't do that if you're not a general purpose server. If you're actually a facade using an underlying relational database, every search parameter is a search parameter that you have to actually code by hand. And you won't support all search parameters, and you never will. You'll have to code every one of them by hand. But irrespective of whether you're doing general purpose servers or coding the search parameters by hand, chain search parameters are always where the pain is somehow. They're the most useful feature of search. You can do some incredible things, but they're also a way to really punish the system. You can't code generate from operation definitions because you actually have to write the operation. It's a point of what an operation definition is, but you can code generate parameter objects, and I routinely do that in my server. It uses generated parameter objects, but then I actually have to write the body that actually does the operation. And then you can't code generate capability statement API operations, although if you're doing a general purpose server, you only write the API implementation once and then just use it for all the different resources. Developing servers is harder and all over the place, and it's really hard to provide more general advice. So I'm going to focus on a very specific issue, which is a common question. I have to implement multiple implementation guides. So I've got multiple different advice. What am I going to do? So a couple of things to say. Mostly, not always true, but mostly, a client is focused on a task. At any given thing that it's doing is task focused, and that probably means that you're only dealing with one implementation guide. I'm reading a US core observation, or I'm working on a Da Vinci based exchange, and so a client is inherently mostly focused on one implementation guide. On the other hand, servers, they have a single, while you're running a server, you've got multiple implementation guides to support. The question is, can you do that through one server, or do you need more than one server? And there's really three possibilities. The first is, I have one server and it supports one interface, and that interface conforms to all of the rules of all of the implementation guides. That's obviously the best outcome. Or it may be that I need to tell the server somehow that which implementation guide the client thinks it's doing, so that it can customize what it does a little bit, because they're kind of nearly all the same, but maybe they're a little bit different. Or maybe it turns out that they're just, yeah, they're all, they're too different in the way the rules they make about the resources. And this is why we encourage profiles not to make unnecessary rules about resources. Because if you're running a server, it's much better to have just one server that just works as a FHIR server, and automatically all of the profiles work. But if the profiles in the implementation guides make inconsistent rules, so here's a really simple one: the status code must have a value of X, and the status code must have a value of Y. Well, look, that's not going to work. It can't happen. And so you'll have to have two servers. But actually, that shouldn't happen. That's a nonsensical thing for them to say. Of course, there are lots of sensible things to say that are actually going to be clashing. So in principle, it's possible to have just one server that supports all the implementation guides. And for me, it's the goal. And for instance, across the set of profile designers, one of our goals is consistency, so that it's possible to do this. One server, multiple implementation guides. The trouble is the devil's in the details. A typical resource, simple resource, has 100 data elements. Each has their own value domain. They might have a implementation guide that restricts the value domain in one direction, in one implementation guide in another direction, in another implementation guide. So then you've got overlapping uses of value domains. So if your value is 10, it was a simple case. The value is 10, it's fine on both. But if your value is -1, it's not legal in one, it's legal in the other. If your value is 100.1, it's not legal in one, it's legal in the other. So the devil's very much in the details, and there's no simple answer. There is some tooling to compare implementation guides. It's written, it runs inside US implementation guides, so the US steering committee can compare them and say, well, are they compatible? Because in principle, the US steering committee would like one server for all implementation guides if the use cases are compatible. It's a very obvious thing to do. But the trouble is there's no binary answer. You actually have to, the tooling generates a difference analysis and a union and an intersection between the profiles. If the intersection is empty, there's no valid resources that conform to both profiles. But in general, the intersection isn't empty, and some resources will conform to both profiles. On the other hand, the union is all the possible kinds of resources you might get if you're reading data that conforms to either implementation guide. So that's your reading problem. We're working on the tooling to make it better, but it's not going to be a simple thing. So we have plenty of general purpose servers, and I've listed them here. And we have custom servers that load, and these are like variations of the general purpose servers. And I've seen a couple of them presented here, and there's more, and I haven't got a list. And in fact, this list here of general purpose servers is not maintained. So if anybody wants to step up and say, I'm going to maintain a list of server software on Confluent somewhere and curate that, that'd be pretty cool. But these custom servers, you actually load them in IG, and then they just express the IG and do a bunch of services like validation to validate the resource conforms to the IG. And they're becoming more common, and they're basically adaptations of general purpose servers. So it's pretty cool. Now there's a bunch of other kinds of development tools that you can make use of. I'm going to run through them very quickly. Most of this is reference material for people who want to look at the presentation later. But there's a bunch of public registries that you can use to find content, for instance, existing extensions or existing implementation guides. There are really capable validators. There's the Java validator, and there's also a .NET validator. Those are the links. They share test cases. We are reconciling on the test cases right now and using that to drive the behavior of the validators to more consistency, but they're not consistent right now, but we're working on that. You can get a terminology server that performs value set validation, expansion, code validation, lookup, and translations. I think if you are developing an application, you are nuts not to use a terminology server. It just saves you so much work and offloads a bunch of specialist problems to a specialist software. And increasingly, there's national terminology services agreements and software. And I think that those are something that everybody should be looking to take advantage of. We have a bunch of visual resource editors, and here's some reference to some of them. They're visual editors for specific resource types. We don't really have an ambition to write a combined IDE for FHIR. Maybe it'll happen in some form someday, we'll see. Maybe you want some example data. Cynthia is a wonderful piece of software that you can download that generates sample data with realistic, semi-realistic scenarios. You can see a bunch of conversation about Cynthia on chat.phir.org. If you have some other options that are simpler, there's a mimic data set in FHIR, although you need to get that from the mimic people. And there's also easier, there's an example data package called FHIR.test.data, which has 100 sets of real patient data from a set of de-identified CCDA documents. So that's real patient data, conditions, observations, medications. If you want to publish specifications, there's plenty of material, plenty of attention going to those, but I just want to point out that you can use those for commercial specification development, and people do. Data mapping tooling. Yeah, we have plenty of data mapping tooling. There's a FHIR mapping language, presentations about that during this meeting. You can use general purpose mapping tools, and there's plenty of niche stuff going on. Everybody needs data mapping tooling. I'm not going to talk about that anymore. Now, testing. The first thing you can do is utilize external testing systems to test your server. This is not a really good framework for testing your client. In fact, they don't work for clients, but you can test your servers. Inferno is a very good testing system provided by the US government. It allows you to test US core, bulk data, Smart App Launch, and IPS. You can contribute additional test frameworks to Inferno. I highly recommend that if you are developing one of those implementation guides, you would use Inferno. In addition, Aegis and Mitre provide Touchstone and Crucible. Touchstone is a pretty full-blown commercial service. My impression from Crucible is that it's not currently maintained. If I'm wrong, I'll be happy to hear otherwise. If you're lucky and you can sign up for Apple testing, then Apple have a very comprehensive set of tests you could consider using. Alternatively, you can write your own tests. We have a test script resource. It doesn't get enough attention. You can write your own test cases, and it's pretty capable. It's actually used inside Touchstone, and most of the implementation guides that publish test cases work with Touchstone. I think test script doesn't get enough attention, but the trouble is there's no general purpose independent runner, open source runner of test script. Or you could use a classic RESTful testing tool. Now, in terms of testing issues, in order to test, the server has to have standard specified IDs for test patients that have data that conforms to particular scenarios or implementation guides. And we haven't got a standard way for the server to specify those IDs. So they're kind of done, there's a text file, or you get it by word of mouth or out of a spreadsheet somewhere. I've always thought we should solve that problem, but we haven't got around to it. And you need test accounts, of course. But more generally, think people about how do you anticipate that people will run tests on site in production? It's really hard to test an ecosystem, and I think this is an area where, in my observation, we really fall down. How does a hospital automate their own tests on their own system, or an institution do so? One of the things I've noticed in production when I'm actually in clinical environments is it's too hard to have a test system that everybody's authorized to use that is fully connected to all of the peripheral systems, whether they're devices or other systems. It's way too hard to maintain that. And so clinical staff routinely have test patients and test accounts, so forth, on the live system. It seems to me like it would be a good idea to do something about that on the system, but don't seem to have to see that very often. Finally, of course, there's security. I did have to mention security, so I have. So there you go. Have mentioned security. Oh, this is the wrong slide, so I figured about that slide. So I'll stop and I'll take questions. In the few minutes that we have left.
And as a reminder to those participating, you can ask your questions in the Q&A in Whova to the right of where you selected the link to get into this call.
Well, we don't have any questions there.
And I see Christopher did comment, you're not going to be able to unmute, but you can ask them via text in the Q&A there.
Well, should we let people unmute, or is it too difficult to do that?
You can definitely do that if it makes it easier.
I do see one text question that came in. When it comes to package IG versioning, how does the package version relate to the canonical versions of definitional resource? Example, value set, plan definition, library.
That's a great question. It's up to the author of the implementation guide to decide. Typical implementation guide, and we certainly make this easy, imposes a common version on all artifacts. So, for instance, US Core 3.2.0, all of the artifacts will have the version 3.2.0 across the implementation guide. And I encourage authors to do that. But for instance, if you look at UTG, the terminology package, every piece of terminology has got its own version, and there's no relationship between the package version and the versions of the resources inside, because they all have their own life cycle that's strictly managed at that level. So there's not necessarily a relation, but there might be, and we encourage there to be, if it's possible, because it's just simpler for everybody. I know what 3.2.0 means, whether I see it in the profile or in the implementation guide.
And with that, we are at time. So thank you so much, Grahame, for the fantastic presentation on the development and testing strategies. For those joining us, if you do have future questions, you can always ask them in the community chat in Whova or on chat.phir.org. And this will conclude the presentation. Thank you so much.